In this example, we will build a thermostat control with compressor alarm protection using structured text in EcoStruxure Machine Expert HVAC. The goal of this program is to control a cooling system using a thermostat while also ensuring safe operation of the compressor. To achieve this, we use the CompAlarmMgmt function block, which monitors multiple safety signals such as high pressure, low pressure, oil pressure, and motor alarms. If any alarm condition occurs, the system automatically stops the compressor and prevents it from restarting until the alarm is cleared. First, let's look at the variables used in this program. The first group of variables represents the alarm inputs. XE stop. This is the emergency stop input. If this signal becomes active, the system immediately triggers an alarm. X motor alarm. This input indicates a motor protection alarm, such as an overload condition. XHP switch. This represents the high-pressure switch, which protects the refrigeration system from excessive pressure. XLP switch. This represents the low-pressure switch, which protects the system from operating with insufficient refrigerant pressure. X-oil press switch. This input monitors the oil pressure safety switch, ensuring proper compressor lubrication. X-generic alarm. This is a general alarm input, which can be used for any additional fault condition. X-reset alarm. This input is used to reset the alarm state once the fault has been resolved. Next, we have the alarm status variables. UI alarm ID. This variable stores the identifier of the active alarm, allowing the system or HMI to display the specific fault. X-alarm active. This variable indicates whether any alarm condition is currently active. Next, we define the function block instance. CompAlarm, CompAlarmMgmt. This function block manages all compressor protection logic and alarm monitoring. Now we call the CompAlarmMgmt function block. The second part of the program implements the thermostat control logic. However, the thermostat is allowed to operate only if no alarm is active. The program first checks. If no alarm is active, the thermostat controls the cooling output normally. If the measured temperature from the NTC sensor becomes higher than the set point plus the differential, the cooling system starts. This means the compressor command X cooling becomes true and the cooling output is activated. If the temperature falls below the set point, the cooling system stops. This creates a simple thermostat control with hysteresis, preventing rapid on-off cycling. If an alarm becomes active, the system immediately overrides the thermostat. The compressor command is forced to OFF, and the cooling output is also disabled. This ensures the compressor cannot run while a safety fault is present. To summarize the operation of this program, the PLC continuously monitors several compressor safety signals using the CompAlarmMgmt function block. If any protection device detects a fault, the system activates an alarm and identifies the fault using an alarm ID. While the alarm is active, the thermostat control is blocked and the compressor is forced OFF. When no alarms are present, the thermostat controls the cooling system normally based on the temperature set point and differential. This approach ensures both reliable temperature control and safe compressor operation, which is essential in HVAC and refrigeration systems.